All right. Finally get. We're still going. Okay. I go. Okay. Plenty of time. Come on, Frank. Thank you. Normal coordinate plane. If I put a circle on that, how many sections is it broken up into? So if I want eighths of a rotation, what is each of those sections worth in degrees and radians? Pi over 4, and it is 45 degrees, yes. So if I go 3/8 of a rotation negatively, that means I will go 1, 2, 3 this way. So you should be at negative 3 pi over 4 or negative 45 degrees. Negative 135. I just did reference angles with last hour and then Frank crapped out on me. Negative 3 pi over 4 or negative 135 degrees. There we go. what was it? One cone in both. Gotcha. So describe all coterminal angles in degrees and radians. Those are easy. Negative 3 pi over 4 plus 2n pi. N is an integer. In degrees, negative 135 plus 360n. N is an integer. If I want to draw them in radians, then if I went 3 pi over 4 here and a whole circle is 2 pi or 8 pi over 4, I need to go 5 pi over 4 that way. If if I went negative 3 pi over 4 and I need to go more for another negative angle, we're going to go all the way around the block and try it again with an additional 8 pi over 4 that is negative, turning it into negative 11 pi over 4. There we go. Did you, green, did you have the correct angle? And because kids will screw this up, and put it in the right spot. Because I'll have kids who say negative 3 pi over 4, but then they put it up in like quadrant 2 for some reason. Okay? Or they write negative 135, but then they put it in quadrant 4. Or they have it in the right spot, but then they call it like negative 3 pi over 2. I don't know. So two separate. Did you have the right angle? Did you have the angle in the right spot? Did you have the positive angle correct, drawn in the correct spot? Did you have the negative angle correct, drawn in the correct spot? And these were just slap that stuff onto the angles. So again, if you had these angles wrong, this part would be wrong. I'm asking, did you have the that? Did you have the set builder of alpha plus 2n pi, alpha plus 360n, where n is an integer? Okay? Those are your 5 parts to it. Anything about it? Okay. Frank.
Frank is not doing so well.
When Frank craps out, that just means that you have to do more on your own later. Homie work. Anything about the homie work? Going once. $32. Oh, radians times radius. You actually have your choice. Remember, if you want to do radians times radius, first you're going to have to do 150 times pi over 180. Divide both by 30. 5 pi over 6. Now I can do radians times radius to get my area, or this was arc length. The alternative is you could have just done 2 pi r times x out of 360. Okay? New school, old school, both get you the same answer. Either one. Others? Okay. I have to. No. Bad Frank. There we go. All right, if we got nothing there, then we got nothing there. No. Then we left off. We left off. We did the thing, and then I said multiply, and everyone ran away. Right? Did you multiply? Have you ever wondered why you randomly have 23 out of 25 on your notes? Those things, I'm like, hey, you need to do this, and then you don't do it. So we should have gotten through that. What we haven't been able to do is, God, I hate you, Frank. Oh, wait, you're... No, you're calibrated. It just doesn't want to do touch input right now. Okay. Then, your turn. You ever torn apart a disk drive?
Yes, I have been in my room.
Seen how fast they go? Yep. Have an old DVD player or something, and you can hear it going thunk, 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 thunk in there. These things are, they spin very fast. And if you take the little pressure ball bearings out of the center clip that holds the CD in there, you can kind of turn it into a frisbee launcher. Yeah. Yep.
There's a couch right there.
Always do it in terms of pi and then the decimal equivalent.
It says send it.
There you go. There you go. That's what we like.
We have to get the meters, so we do.
Yeah. That's right. I don't know where to go after this. How many? Okay. So,
Why are you going inches to meters?
Yeah.
What?
So it'd be 1,000 on the bottom, and then I don't know. Then you divide.
Yeah. 1 radian is 1 radius. What's the radius of this disk?
I don't know. I don't know.
How do I go from revolutions to radians? Okay, 1 revolution is 2 pi radians. Quiet, you. Why didn't I write it again? Sleep deprivation.
Which means that we have caught the first hour of PreCalc.
There you go. 7 pi radians per second.
Yeah.
Which is 21 threes and like 22 something. I don't know. Little.
1.99.
Hmm? Well, you would say it's 7 pi radians per second. That's the correct answer, but the 21 point whatever is what most people are going to understand.
So
There's a difference between this is the accurate answer, I am correct, versus the one that people will accept. We're going to say the real one. Okay? All right, let's see if we remember how this works. If I start with 3 revolutions to 1 second. First things first. Okay. 60 seconds is 1 minute. We know that. That part's easy. Do we remember the magic portal? 1 radian, which is rotation, is 1 radius, which is length. So I'm now in revolutions per minute. I'm never going to get over to meters unless I cross through that gate. To get through that gate, you better have your ID on you, which in this case is radians. Swap it over to radians. There is 1 revolution to 2 pi radians. Like we said yesterday, I've always done like coordinated slashes or X's or whatever, so you actually know what you did instead of just a bunch of crossed out stuff. Okay, I am now in radians per minute. I am at the gate. I have my ID. I'm allowed to say that 1 radian is 1 radius. So I look at the picture, and what is 1 radius? 60 millimeters. So, radian, radius. Do we remember metric? How do I switch millimeters over to meters?
No, divide by 100.
No. Milli is a prefix for 1,000. 1,000 millimeters is 1 meter.
That's what I was getting by.
And you multiply straight across. You say 3 by 2 is 6, 60, 60, so 5, 60, so 216, double zero, 260, 21,600 over 1,000. Hmm, hmm. 216 over 10, divide by 2 is 108, divide by 2 is 5, 108 pi over 5, or 21.6 pi, a little over 21, a little over 3, 64-ish.
67.
Ah, crap. So
Close.
that's pure guesstimate right there. Can you do that? Do you have this written down? Is this like highlighted, circled? You have to go through this portal to get back and forth between linear and angular. Okay. Now, what some books will do, what some kids need to do, is they need a pit stop in between here. Some kids do not like this unless in between I put 1 radian is 1 radius. And then would that make more sense? Some folks would rather say 1 radian and 1 radian than 1 radius with 1 radius, because 1 radius is 60 millimeters. It adds one extra step, but for some people, seeing that is what makes it click. That a radian is a radius. They have to have this in every one of their problems to make it stick. If you need it, use it. If you can jump from a radian is a radius is that many, whatever length they give, use it. Yes, ma'am.
So from yesterday, is it just the same thing? I said 1 radian equals 1 rotation.
No.
That's what.
A rotation is 2 pi radians. A rotation is all the way around the circle.
Yeah.
But all the way around the circle is 2 pi radians. A radian is a radius. Okay, a radian is that much rotation. A radian is 1 radius of arc length, 1 radian of rotation is 1 radius of arc length, because I'm taking this radius and I'm going that far around the circle. Okay. Do we need another? I'll make it up. Okay. I'm seeing vigorous nods from some. So, and you won't let me do the thing. There we go. Oh, somewhere down there in the bottom corner, I guess. Let's do... We gonna Google. All right. Typical paintball gun is 300 feet per second muzzle velocity. Turn that into miles per hour.
Are we gonna use the bottom of this?
Oh, wait. Because I want rotation. Sorry, I did this with the freshmen when we did unit analysis in algebra half. Oh, there we go. The crankshaft in your car. The center spindle on the crankshaft of your car, I'm going to say, is a beefy one. Maybe it's meant to take some abuse. Okay, maybe this is more like a tractor. Okay. The crankshaft in your car has a diameter of 2 inches. Maybe you just got a really, really big, beefy. This is like Mad Max car. Okay. And you rev that thing up to 4,500 RPMs, revolution per minute. I would like to see what is that revolution per minute in that thing is spinning how many miles per hour?
Are we doing the free example on the bottom?
We're doing one of them. Revolution per minute. It's in your. It's right there in front of your face when you drive.
Yeah, it says RPM, not revolution.
I'm trying to find a tank's crankshaft.
Yeah, 2-inch crankshaft. That's like an old John Deere 4500. Boy, we were having a day.
And it was all
Instead of arguing about your poor driving skills, let's do the problem. Uh-oh. I'm just making up numbers. I don't care what the answer is. I just want to see if you can do it. My spatula is broken, by the way, so some of you are getting brownie piles.
Well, I know, because there's 12 inches.
Y'all, this is freshman physical science. It shouldn't be this much of an argument. 4,500 revolutions to 1 minute. Switch minutes over to hours. Switch revolutions over to radians. You have radians. You are at the gate. You have your ID. You're ready to go. Go through the gate by saying 1 radian is 1 radius. 1 radius is 1 inch. Now I need to go over to miles. 1 inch? No, 12 inch to make a foot. And then, one of my favorite movie lines of all time, how many feet in a mile, Petey? 5,280 feet. Yeah, and pick up this ball and run every one of them. Oh, that's Denzel Washington is hands down my favorite actor. So, revolution with revolution. Minute with minute. Radians with radius. Inches with inches. And feet with feet. So all together, across the top, 4,500 by 60 by 2. 2, 62, 29,000, 90,000. And then 120, so double zero. 45,920? Or 53,200?
Neither.
Oh. Oh, I ain't got it. Something pi over 5280. Oh, no, times 12. Get a calculator. Someone help me. I'm tired.
0.775.
Ew. In pi.
Why in pi?
You give me the real answer and then the decimal equivalent.
I got you.
Okay. Is it literally just not calibrating the touch?
Second.
Why would the pen work but not the touch? No? Okay.
No.
I hate you. Okay. Yo, I can't bring the calculator up here because Frank's being dumb. You have to actually press buttons.
No. 375 pi over 44. No. 375 pi over 44.
Kenyon, you seem to get stuff right when everyone else is arguing. What do you got?
375 pi over 44.
There we go. 375 pi over 44. Which, when multiplied out, is how many miles per hour?
26.775.
Okay. Me and Frank are going to have a talk after this. No. We need to do 14 because they assume that you just can do this, and in my experience, kids just can't wrap their head around this without an explicit example. It is in your book. It is going to be on your assignment. Sometimes you got to come at something from both angles, and it doesn't help when the way that they wrote the directions is dumb. Find the rotation in revolutions per minute given the angular speed and the radius given the linear speed and the rate of rotation. That reads like a run-on sentence. It's two sets of directions. Find the rotation in revolutions per minute when given the angular speed. Find the radius when given angular and linear speed. So remember the portal, the gate, is 1 radian is 1 radius. So if they give me angular speed and linear speed, they can meet in the middle to find the radius. So I start with my linear speed was 32 meters to 1 second. My angular speed was 100 revolutions to 1 minute. I will not be able to compare these if they're in different units of time. Something happening per second versus something happening per minute, those are very different. For example, if you are paid $17 per hour versus $17 per shift. Well, what if my shift is like a 4-hour shift babysitting someone's terrorists? Okay? That's our children are referred to as goblins, spawn, or domestic terrorists.
Tell them that?
Sometimes. They're 2 and 4. Get over here, you little goblin, and then he goes and runs at me and tackles me. He doesn't know what that is yet. Okay. Oh, if I'm sitting on the ground, Baby Bear can knock me over. Yes, very strong baby. These are in seconds and minutes. I need to make them in the same unit of time in order to compare them. Do you want to turn seconds to minutes or minutes to seconds?
Seconds.
Would you rather multiply by 60 or divide by 60, right? So, 60 seconds is 1 minute. Apparently, dividing is now cringe. Okay. Seconds. Okay, I'm now at this many meters per minute is this many revolutions per minute. This is a length, but to meet at the gate, to meet in the middle where a radian is a radius, I need to have radians. So over here, I'm going to switch this into 2 pi radians is 1 revolution. And now in the middle, they are both in minutes. I now have, what is that, 1800 and 1920? 1920 meters is equal to 200 pi radians. Yes, it is. When the radius is a particular length, which is what we're about to find. This much length is this much rotation. If a radian is a radius, then I can say that 200 pi radians is instead 200 pi radii, plural of radius.
Is that actually?
Yes, radii. Kind of sounds like Yoda saying that he's ready to go. Radii. Radii is plural of radius, so I have 200 pi radiuses, which means if I divide by 200 pi, I have divide by, a radius is 1920 over 200 pi. 1 radian is 1 radius. Length is this much rotation. So if I get any length equals this much rotation, I can divide by that rotation to find out what the radius is. You have to be able to meet in the middle, though, where you get a length equals radians. You have to meet in the middle where a length equals radians in order to find that. Because if length equals radians, then the length also equals radius. Okay? When you do this, y'all got a calculator. Again, Frank's not really working right here. Be aware that if I say 1920 divided by 200 pi versus 1920 over 200 pi, those will result in different answers. Why?
Because you're divided by 200.
That's the way it takes the pie.
Mm-hmm. Division is a lie. This is why Aunt Kathy argues with people on Facebook about that one math problem. Because everyone thinks that this just tosses parentheses on there. That this means fraction bar. And it doesn't. Division is a lie. This says 1920 times 1 over 200 times pi. Division does not really exist as an algebraic structure, so that's why when I run into multiplication and division in PEMDAS, I do them left to right like a book, because they're the same thing. Do you please remember, do you all remember that whole, okay, most people are the, please excuse my dear Aunt Sally, the one that we always learned, please execute my deranged adolescent sister. There's one kid years ago who just hated his sister, right? It's parentheses, exponents, multiplication, division, addition, subtraction. The problem is, if these are the same thing, you have to group them and say left to right like a book. I don't really subtract things. I add the opposite, so these happen left to right like a book. Okay? So please be careful when you type that into your calculator. You probably ran into that problem in geometry. How many times did you divide by 3 pi and you got the wrong answer? Oh wait, I have to divide by 3 and then divide by pi. Okay? Okay, right after that, basic formula. Yesterday we talked about the circumference of a circle is perimeter all the way around, so I can adjust it by a portion to find the arc length of just part of the circle. I'm going to do the same thing to the area. Back in geometry, we said the area of a circle is what? No.
Pi r squared.
Pi r squared. 2 pi r is circumference, pi r squared is area. So if I want the area of just a sector, a pizza slice, a wedge of the Trivial Pursuit pie, and I know that it's x degrees, we took the portion of that formula the same way we did with our arc length. It's going to be pi r squared times x out of 360. This is how you saw it in geometry. Well, what happens when I take x, my degrees, and convert it over to radians by multiplying by pi over 180? Cancel, 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 cancel. And you get this if it's in radians. Okay? So you have two formulas, and you do have the choice of which one you want to use. You can be in radians, use the radian formula. Be in degrees, use the degree formula. Or I don't like thing, so I'll convert my angle over into the other so I can use the other formula. Whichever your jam is. Okay? Just having to come over here for the mouse feels like I'm back in the 90s. Like, hold on, let me get rid of the marker on my overhead projector. You had at least one teacher that did that, didn't you?
Did what?
There's still that one old teacher that refused to use a smartboard at all. And they did that overhead projector with the little clear transparencies. And they had that disgusting rag to wipe them off. Y'all, that's what my second grade teacher did. Okay. So over here, find the area of the sector of the circle. If it's already in radians, I'm going to use that formula. Area of the sector is 1/2 radians times radius squared. Well, 3 squared is 9. 9 by 7 is 63. 63 pi over 8 by 2 is 16. 63 is awful close to 64, so 63 over 16 is about 4. Times about 3 is going to be 12 and change. Maybe?
12.37
Okay.
with 2 zeros after.
So you would give me that centimeters squared, because we are talking about area, and then the 12 point, you said 37 bunch of zeros? Okay. To do the next problem, do you remember the donut problems or the dartboard problems from geometric probability? Where they'd say something like each ring is 1 inch or each ring is 2 inches. Find the area of the shaded portion. And in order to do that, you have to double donut. You would have to take the big circle minus the second circle. Big circle minus the next circle to get rid of the middle of this donut. But then you got another one inside there, so I'd have to add my idle donut and subtract my donut hole. Okay? Do you remember doing that when it was also And then they were alternate shaded, like a dartboard. What is the probability that I throw a dart, it hits this dartboard at random, and it hits a point value that is 10 or more? You know, I kind of want to do that to you now. Because you should have done it in geometry.
We did.
We did, and we're traumatized. Okay. That concept is the same with arcs. It's the same with an arc, where if this is the entire arc that the windshield wiper covers, the entire arm, one wiper. This is like those itty bitty mini cars. Okay. This is the go-kart that's like on a pop trailer behind the $200,000 RV, right? But the problem is, this is the only portion that it's actually wiping, because that's where the wiper is. Okay. So they tell me this is 130 degrees. They tell me that the windshield wiper portion is 16 inches. And then over here, we are told that the entire arm is 26 inches. So if I can do the donut thing with an entire circle, I can also do it with arcs and sectors. So now I'm going to take the entire arc. Do you want to be in radians or degrees? Both will work. Okay. I'll do both. They're not hard. So I'm going to have pi r squared times x out of 360. That's the entire area that the arm mechanism moves over. I have to subtract the area I don't care about. What's the area I don't care about? Or what's the radius I don't care about? 10, not the 16. The 16 is the actual wiper. I don't care about the 10 below that. Times 130 out of 360. So big arc minus little arc. If I was in radians, well, 130 times pi over 180, cancel out the zeros, is just 13 pi over 18. So 1/2 13 pi over 18 times big radius squared minus 1/2 13 pi over 18 little radius squared. Write your answer in terms of pi. I don't care, degrees or radians. You notice they have something in common. Okay, so you can factor something out if you need to. 26, what is that? 400, 120, 120, 240, 640, 676, 100, 576. 576 by 13 over 36. 576 and 36 are divisible by 250, 36 to 38. 288 over 18. Keep going. 144/4, keep going. 72/2, keep going. Oh wow, that's divisible.
Yeah.
36/13, 360, 108, 208 pi.
Yep.
Right?
Yep. Good job.
I'm tired. It took longer than it should have. You get 208 pi. And then times the actual pi and get about, what, 330-ish?
Would it be like 600?
Oh, 630-ish? I said, I'm tired.
653.451.
653 and change? Okay. So, whether you're just plug it in the formula and done, or you got to do a little bit more work to it because of area of sectors also relating to our donut problems from way back when. Okay, you look up here and it's just blah, blah, blah formula, right? You don't even have to do the donut thing. So we say, yay formula. Which, what are y'all, about 16-ish?
Yes.
Since Monday.
Give it about another 6 years or so. You'll be saying that again.
Six years? I don't know about that.
Do you know how many people, particularly in a very narrowly defined privileged community, are going to just check boxes? I graduated in high school. I must now go to college. I am at college. I must find the one. I will graduate college and I will immediately get married. Oh, I'm married. I'm going to have kids. And then you're about 24 to 26 years old and you have a kid. And then you realize, oh, wait, I'm not emotionally mature enough to be with a person and have the responsibility of being a parent. So then you get divorced about 5 years later.
Sounds about right. Is that all?
Divorce rate is at about half of all marriages in the country. So, and formula is expensive. Ha, you're funny. No. We're going to get 4-3 up here. We've got time to get started on it. This thing right here, just to remind you, it's coming. Okay?
When will be our weekly quiz?
Monday we will finish 4-3. Tuesday you will take test. Wednesday, all of your notebooks will be over here and held hostage because you will be taking a no-note quiz on the unit circle and special right triangles.
So we get it on a quiz for Tuesday?
No, you're going to get it Wednesday because I'm grading books during our early release shortened classes while you are doing a no-note quiz.
So we get our notes on Tuesday, but not Wednesday.
Yes.
Okay.
Where did PreCalc go?
Yeah.
I closed the wrong notes. It's really bothering me that I can't actually use this. Okay. If I have a coordinate, we all know that a coordinate is an x and a y. Well, if the angle used to make a radial line going to that coordinate can be defined as the hypotenuse of a triangle, now all of a sudden I get not my angle theta, we're going to call it theta prime, it's called a reference angle. And since we know x's go this way and y's go this way, I can say that X is my adjacent, Y is my opposite, and my radius is my hypotenuse. This is how we're going to start developing the unit circle, and we can relate physical figure geometry over to coordinate geometry. I don't want to. Hey? Okay. Yep. Maria, you were being sacrificed to the office gods. She used the words real quick, so I'm assuming you'll be back. So, if you would, right next to this, we're going to write that X is adjacent, Y is opposite, and R, my radius, is my hypotenuse. You say, well, how's that going to work if I'm over in that quadrant because X and Y are negative? You just said that I have a triangle where there's a negative number here and here. You can't have negative length. These are on a coordinate plane. It doesn't denote length. It denotes direction. A negative X just means left. A negative Y just means down. And if I have those, and opposite adjacent hypotenuse can be rewritten as X, Y, and R, you get coordinate shortcuts, so you don't have to draw the triangle anymore. Cosine is Y over R. Or sorry, sine is Y over R. Cosine of X over R, and on and on and on and on. I want you to look at the tangent, cosecant, secant, and cotangent functions. Why do they all say that? You cannot have it equal to 0. Why is it only X and Y? Why don't they care if R is 0? R is on the bottom, sine and cosine. What do you mean?
Well, you can't.
You're sniffing down the right trail.
If R is 0, you don't have a circle.
You don't have a circle, you don't have a line. If the radius is 0, then it's just a dot. So that's why they don't care about R. Okay. Additionally, we have, I talked about it before, we have what is called the quadrantal angles. It just says, it's fun to say. Quadrantal angles means it's the angles at the quadrants. 0. Oh, did you get a B-buck? Oh, that's what my kid gets at daycare for doing something good. B-bucks, and then they get to use them to buy little toys and trinkets and crap. Okay. Yeah, capitalism. Okay. 0 degrees. I want you to think about this if it was a triangle. Think about this as a triangle. I'm going to do this just so we can wrap our head around it. If this is at 0 degrees, the radius is here. What's the opposite going to be if it's 0 degree angle? 0, right? Because there isn't any vertical change at all. It's just right on that horizontal line. What is my adjacent going to be? The radius, because this is just going to fall down. That's why right here they wrote the x coordinate as just r. Okay? So instead of calling it like 5, 0, which would be a normal coordinate, they're going to call it r0, showing you that this works for everything. Okay? And then I'll have 0r, negative r0, and 0, negative r at the other quadrantal angles. Oh, randomly, I remembered this from like 5, 6 years ago. I had a kid who really struggled with the whole, but on a unit circle, if this is 2 pi, and this is pi, and they really struggled with this idea that one revolution was not 1 pi. They really struggled with that until randomly I was like, well then just stop trying to call it a pie. Call it a calzone. Where if I say pi over 3, I want you to think calzone over 3. Take a third of the calzone. Right there. It worked for him. I said it last hour, and there was like 2 kids who were like, oh, okay, we're good. If it works for you, it works for you. If it doesn't, then why are we talking about calzones? Okay. So, all those little coordinate shortcuts, we're going to use them now to let 8, -6 be a point on the terminal side of an angle in standard position. Go find all of its trig ratios. Well, the old school way to do this was draw your triangle. I'm going to erase this later because I don't need to do it. Where is the coordinate 8, 6? Quadrant 1, 2, 3, 4.
8, 6 is 4.
Go 8 this way, 6 that way. Okay, so there's 8, -6. This is my coordinate, 8, -6. Yes, you can put -6 as a side length, because when you do Pythagorean to find your missing side, don't you square that anyway? And -6 squared is still positive 36. 36 plus 8 squared is 64 is 100, and the square root of 100 is, did we recognize our 3, 4, 5 triangle? Okay, so maybe another little note to put to yourself is that the radius is always positive. The radius cannot be negative because it's defined as the distance from 0, the distance from the center of the circle. And then if I'm here, well, this is the entire angle, but the one that we're talking about is little theta prime, and the trig values of theta will be the trig values of theta prime, so I can just find my 6 trig values from right here. What I'm telling you is that you don't need to find the sine of theta, cosine of theta, tangent of theta from that triangle. I don't need to have it at all. Because now I have my coordinate shortcuts. Yes. My coordinate shortcuts are simply y over r, x over r, y over x. The word's tired. R over y, r over x, and x over y. See, from here I can label my opposite, adjacent, and hypotenuse, and I can find all of those normally. I'm telling you that you don't need to, because instead of this, I could just have 8, -6, x, y. R is the square root of x squared plus y squared is 10. I don't need to draw this out if I have my coordinate shortcuts. If I understand that the opposite side of my triangle formed with the x-axis will always be the vertical movement, which is y as a coordinate. And then plug your numbers in. Y over r, reduce. X over r, reduce. Y over x, reduce. -3. Flippy, flippy. I said flippy, flippy way too many times last hour, and I was concerned about who's going to start flipping off their friends in class and just giggling, flippy, flippy. In this room, I do believe that would be Nick. Sounds about right. I don't have to draw the triangle, is what I'm saying. You do not have to draw the triangle if you have the coordinate rules. So, if you got the coordinate rules, all you need to do is, here's x, here's y, find r, plug them in. And that is exactly what I'd like you to do down here, except you're going to do it with this guy. Okay? We're not going to do it with 1a because 1a is just another 3, 4, 5 triangle. We're going to do 1b because there's negatives in there and, oopsie, get a radical. So you have to rationalize. When you are done with this one, ladies, if you would collect your ransom. It's always ladies first. You, come get food.
Thank you.
Mm-hmm. Apologies for the few that turned into piles. Mm-hmm.
Thank you.
Yes, ma'am. Mm-hmm.
Thank you.
Mm-hmm. Then all of the fellas. Whoa, that just like fell off of there. Mm-hmm.
Thank you so much.
Yes, sir. Yes, sir. Mm.
It finally happened.
Right.
My binder fell apart.
Yes, it did.
But still it fell all the way apart. I think it'll last. It'll last you at least another 2 years.
I said I was going to take the
And the high
tried to get
school,
Tuesday instead, and then
you might get a new one after.
If I still have a physical one, otherwise you just do it from the video.
okay.
Yeah. You should have. Y over R and rationalize, negative root of 5 over 5. X over R and rationalize, negative 2 root of 5 over 5. Y over X, positive 1/2 when my negatives cancel out. Flippity floppity and say R over Y. So now it's going to be a negative root of 5. Now it's going to be a negative root of 5 over 2, and then a positive 2. Cool? You can do this by just making the triangle and doing what we did a few days ago. I don't care. I'm just showing you that there is a different way, and that different way is going to lead us towards building the unit circle. This idea that I can rewrite portions of a triangle as x, y, r coordinates. That's what's going to lead me to the holy grail of trigonometry. Okay, then they talk about the quadrantal angles. See, these ones, it's going to be a little bit harder to find what they are because they're in weird places. See, if I ask for the sine of negative 180, I got to remember that at negative 180, what's my coordinate? Back to that first slide. Why are you all packed up?
You packed up, so I packed up. I finished the videos.
All right. Well, we went through example 3. Have fun.
Oh, sweet.